like passing knowledge of what steganography is. It's pretty, okay, so you're gonna get bored in the first few slides. Just saying. And steganography, it goes back to the Romans, you know, so lots of stuff. So when I was putting together the presentation, I was thinking, like, should I tell all the Julius Caesar ciphers or something really, really old and boring, or go for something more current? So I went ahead and brought something more current. You probably are more familiar with this guy rather than Julius Caesar. So the story about this Arno, it's a funny one, right? It was back in 2009, and I promise it has to do with steganography. Bear with me. So Arno, he had a very bad argument with some other member of the committee of the California Senate, and this guy Tom Amiano, they had a big argument, and he even insulted Arnold in public. He said, like, kiss my ass, something like really nasty for a politician. So right after that, Tom Amiano tried to pass a bill. It was just a totally normal bill, nothing really out of the ordinary. What was Arnold's response to that? That was Arnold's response. Let me tell you, the members of the California State Assembly, I'm returning Assembly Bill 1176 without my signature for some time. We've been kicking down the can, blah, blah, blah. So it was just, you know, just saying no. I'm not passing the bill. And then the press discovered that if you check the first letter of each, you know, what was Arnold saying here? That's steganography, right? That's encrypting, not encrypting, but hiding the message so that it's not readily seen, right? It looks like something else, but in fact the message is in the left-hand side, right? So Arnold was, what happened there? All right.
Both green. That should start coming in into selected. We have anything over there. What exactly did they? Why did he make that one? So it off and back on again.
Reboot.
This one both might have very red. This one has to be both green. This one has to be both red because they moved it to the different input.
Back to Arnold. So this was, in fact, yeah, Arnold saying, yeah, Tom Amiano. So it's steganography, right? It's hiding a message within another message. Or when we're going to put it in the context of malware, using an unexpected channel in order to send the message, right? So we're going to see how the bad guys are using strange channels, right? Like HTTP to send something different. Like, we're going to see plenty of examples of this. The most common trick is the least significant bit. So what this consists of is it changes ever so slightly, like 1 bit at a time, the colors of an image, so that it encodes information 1 bit at a time. At the left-hand side, you see the pure white. That's 255, 255, 255. That's the encoding for pure white. And then in the center, what I've done is I've shifted it slightly. So it's not pure white, so it's slightly gray. So I'm putting it a little bit darker than white, but ever so slightly. So it's a 254, 254, 254. Now, the color, you can't see. Human eye cannot see the difference, right? At the right-hand side, it's 252. You can't see the difference. So if you start changing the pixels of an image so that you encode 1 bit at a time just by shifting the color so slightly, then you can put information within an image without the human eye being able to tell whether there's a difference or not. For some reason, when the steganography in the digital side of things, not in the physical domain, but in the virtual domain, started to become something back in the 70s. They started using the Playmate of 1972. That's Lena. Welcome, Lena. There's also another one which is a monkey, but you know this is better than a monkey. So For some reason, they started using this one. This, by the way, I was researching to put this picture, and there's a new picture side by side. Lena back then, Lena today. I'm not showing it. I mean, Playmate 1972. Yeah, imagine the woman. So this is Lena. This beautiful picture shifted slightly to encode a message. The left one is the real one. The right one has a message. If you look at the histogram, you'll see that there's a little bit more spikes. A little bit more spikes. The human eye would never be able to tell whether there's anything happening or not. So you can encode messages. Bad guys are going to take advantage of this, and you'll see it in a while. Now, I'm talking about the bad guys. Who are the bad guys? What are we talking about when you say the bad guys? What's the first thing that comes to mind when we're talking about the bad guys? What do they want? Cyber criminals, right? Yeah, money. The bucks. Yeah, that's what they want. That's what they want, right? What interest do these people have to hiding stuff? To stay undetected for longer so that they can get more data. Besides these guys, there's two more groups of people, or main groups of people, that are interested in hiding stuff, which is these guys here, not necessarily the US only, but, armies, people that want to spy. So instead of wanting the bucks, what these guys want is information. So they want to stay undetected as long as possible. Steganography is going to be especially useful to this group of people. And the third group of people who also are attacking in the internet, bad guys, spreading malware around, are these guys, right? Hacktivists, terrorists, call it what you will. What these guys are after is not money, is not data. They're after the reputation. They want to destroy the reputation of the companies. They want to smear it down and be on top. That's what they want. You just want to destroy any credibility or trustworthiness that the infected victims might have with their customers. Now, what interest can these guys have in staying undetected? Well, the more data they can accumulate, the better, because at the end they deepen their foothold in the network. So all three kinds of guys are interested in steganography, and you'll see examples of almost all of them. The hacktivists, at least those groups, I don't think they're using it much. To make things more confusing, these three people overlap a lot, like a lot. You see that some of these hacktivists, they managed to steal a database of information, like in Sony in 2011, a whole database of credit card data of Sony customers. And then 2 weeks later, somebody starts spamming them. Probably not the hacktivists, right? The hacktivists were already did their job. They make the Sony look like crap. But of course that database is worth money, so they sell it, and they sell it to cybercriminals. So cybercriminals start using that data. And then at some point somebody sees, okay, we have access to Sony, so another corporate competitor of Sony might have that data and start spying on them. So it's blurry. The edges blur a lot. So I'm going to start using, by way of example, different malwares that do different things with steganography, trying to hide stuff. So what I divided my presentation in different categories. The first category is going to be trying to hide second stage malware. Now, this is not terribly useful. Well, by the way, Arnold's going to tell us, yeah, hiding the payload. So, hiding the second stage malware is not super useful. Why? Because at the end of the day, if you have an image instead of a compressed exe, the end result is the same. I, as a virus analyst, see that, and it's a BMP instead of being an encrypted blob. Might as well be encrypted. So for me, it's not a terribly useful kind of use of steganography, but it does exist, and I'm going to put a couple of examples, like this one, the Lurks downloader. This is just a very generic downloader. It has a BMP, and at the end of the BMP, and this is the edge of the BMP, it has what looks like random data. That's not random data. That's code. It's actually encrypted, but it's code. This image comes from, I think it's Dell SecureWorks. I was not able to find this thing. What I was able to find instead, I don't know if you're going to be able to see that though. Yeah, is this, which is not a pretty BMP. So it's just, it's a BMP, so it's attached within the exe as a BMP, but it actually has no image. So it's just pure encrypted data, just an encrypted blob. Now, you might say, well, this is not really steganography. Well, it is declared as a BMP. It's just not trying to fool anybody because nobody's going to look into the BMP. You know, it's just embedded into the exe. So, yeah, not terribly useful, I tell you. Now, what this stuff decrypts to, well, actually, it goes to this, and this is the really interesting part. It goes to any of these places, which are being used as CNC, and it downloads another BMP. And now this is the real cool stuff, right? This is the BMP that it downloads. Now, if you are a device that is looking this download, you see the BMP. I think it was a BMP. Yeah, it was a BMP. And you see this, just white, right? If you actually look at the picture, you'll see how, well, the part in black is just the header, so it's just some header data. And after that is FEFF. Remember that FF is to 155 to 155 to 155, which is pure white. FE, it's one less, it's 254. So you cannot see the difference. There should be a bunch of dots there in gray. But the gray is just, the difference is so slight that you cannot see that. Actually, in there is data encoded, bit by bit. Every FF is a 1, every FE is a 0. And if you put it all together, you make a message. You make a message which is actually another download place. This is what was encoded inside. So that's interesting. That's more interesting than the first BMP. The second one, it's something that came really recent, just June 2015, called Stegoloader. And they call it Stegoloader because it uses steganography a lot, like a whole lot. And it does pretty much the same. It downloads stuff, but they're a little bit more elegant. They use this picture. So this one, at least, you say, okay, that's pretty better than the other BMP. But again, it's the same thing. You know, they use this a lot. So if you are managing a network and you see a lot of BMP downloads, it's very difficult to say whether those BMPs are encoding something or not. It's pretty difficult. So there's a whole discipline, a whole field of trying to see whether a BMP or a GIF or a PNG has information encoded, and the field is called steganalysis. And it is very difficult to perform steganalysis on the spot by seeing downloaded data. It's just very difficult. So for all practical purposes, it's a BMP. It's a real BMP. You can check that it is. It has the headers. It works. So it's pretty difficult to spot. My second category, the first one was hiding payloads, hiding access, hiding code. The second one is hiding configuration, right? Arnold is going to be hiding his tools, the tools of the trade. So the example is Zeus. The latest version of ZeusVM. When you look, this is a part of the dump in the code, and you see how it's trying to download a JPEG /prefer /blah blah /something.jpg. Why would it do that? It actually downloads this thing. Now, it is something. You know, there's data inside. What this data has at the end of the data I think it's in the comment section, actually there's a malware config file. There's the configuration of Zeus. If you are familiar with Zeus, you know that it has an encrypted blob and it decrypts it in memory, which makes it quite tricky for us antivirus companies to actually see what's happening there. Well, this version has it on a BMP. So it downloads the BMP, and at the end, that's the encrypted blob that it puts into memory and decrypts. So when you do that, well, you see this is the encrypted data. It's just an encrypted blob. And when you try to see it, to decrypt, you find the normal Zeus configuration file. Now you see that this particular one, it's attacking, is it France, Spain, and Portugal and Brazil. But you can see already, this is a regular file. Now my second example is similar, but it's interesting in that it infects Android. It's an old one from January 2012, and it has it's a bad download. Right? So when you're infected, you're screwed, and it poses as a porn application. That's why it's pixelated, And the interesting part of this one is that the configuration, it's stored in the icon, in that pixelated icon, which is, not showing that icon. So they hid information that, again, pretty much the same thing, right? It has just a regular header, and then after that it's a marker called text, T-E-X-T, and a bunch of encrypted information. Now the good thing about Android is that you can see the decryption routine, so you can see how it's being decrypted. So you see the data stream. This is pretty lame. I mean, it's the big part here. It's XOR, XOR with a big string, nothing else, nothing fancy. When you decrypt all that blob, what you see is this, which is at the end of the day, this is an Android that when you get it poses as porn. When you get infected, it starts sending SMS messages, just texting some premium number. So that's the configuration, what number it texts, etc. It just so happens to be into the BMP, into the icon. Sorry, it's not a BMP, it's a PNG, I think. Interesting, really cool. You can really go to places with this, because I cannot see readily, until I analyze it very deeply, what the configuration is. In the same case as Zeus, and more so in a more complicated, different platform than Windows. My third category, it's hiding the CNC communication, hiding CNC channel. And this is Arnold showing us suppressing communication. Yeah, he told me that I had to to mask that. So, Morto. Really interesting one. This is really cool because instead of using just a regular HTTP just to get the configuration, it uses DNS. Super cool. It makes a DNS, non-authoritative answer, saying this. Just a DNS request. In the DNS request, there's a text with this stuff. Once it decrypts it, it comes back to this. But again, this is DNS. It never made any HTTP request. So it's very difficult. If you are a security device seeing what's happening in the network, you're never going to find out that that particular request has something interesting for a CNC command, right? So this is pretty sneaky. I mean, really, really sneaky. I don't think anybody would be able to spot that very easily. And the moment that they change this or they create anything similar to this, using a protocol where you wouldn't expect to find this kind of information, and more so when it's encrypted, then it's very, very difficult to find out, to spot. This one, I found it very interesting, but it doesn't really have a name. You know how antivirus companies, we're funny that way, right? Because there's so many malware samples that we see at the end of the day that if an automated system doesn't readily spot it and put it automatically into a family, then we have no idea what it is. So you end up putting it into an agent bucket or a whatever very generic kind of name. In this case, naming was all over the place by all antivirus companies, so it was very targeted. It's a banker, so it tries to infect the user and try to get the banking online credentials. But it affected South Korea, so I called it myself SK Banker, South Korea. Naming is all over the place. Took me a while. So this one, what it does, it infects the victim. It goes to Pinterest. It goes to a set of Pinterest pins, so things like that. Pretty innocuous, right? This pin is not even bad. It's a pin from a real user, so they're pinning this image. But in the comment section, you find things like this. The bad guy had left a comment such as that, right? And in the comment is the CNC. So they're using Pinterest as a rendezvous place to tell the malware where the final CNC is going to be. In this case, it's a bunch of crap, and then you can see A, B, C, and D. That's an IP address. So it just goes to that IP address, 7039.104.113/tongji.html. Tongji happens to be, I think it's something like status or something in Chinese. So it's not even very strange. You know, it's okay. Is that right? It's not even very suspicious if you're looking at this, right? First, you go to a pin, you look Pinterest, normal, JPEG, and then you go after this. It may be anything. So it's not even very suspicious. The next example is very similar, just that it's using, the name is Janica. And it's pretty recent also. It uses YouTube. It goes to a YouTube place, to a YouTube video, and then the YouTube video has a comment. So the bad guy can just write a comment that has a format. Or a very long number, Psy anniversary. Pretty tame, right? Doesn't look like there's anything weird happening there. Now the good thing about this one is that this one is pretty lame also, because it was written in C#. So C# you can decompile it and you can see the code. So when you can see the code, well, you can already see what's happening with that number. It goes there, it checks the number, and more examples of more comments. That's the bad guy commenting. Now, you can see the code. It just picks up that long number, and it starts dividing it and doing an operation, and then at the end of the day, it gets an IP. It gets an IP, and it adds /wp-admin-content, which looks pretty tame. And this was the final result of one of those, you know. So it's pretty easy when it's done in C#, because you already have the code. Same as in Android. When you have the code, then it's game over, because you can already see what's happening. The latest one, I don't have a lot of information on it, because it was released by FireEye. Was it July 29? That's last week. So they released a pretty nice white paper. There's not a lot of details in the white paper, so I wasn't able to locate the samples. But that was especially cool for my taste, you know. And it goes to Twitter, and it has a DGA. It has an algorithm where every day there's a different Twitter user that is supposed to be tweeting something for this Trojan. Now, if the bad guy doesn't want to communicate today, then he doesn't need to register that user. But the day that he wants to, then he just registers the user. And again, it's an algorithm that the client knows and the bad guy knows. So he creates today's username, and he just needs to tweet something like that. Now, that link points to a GitHub with an image. And then the second part is 101doctal. It's a hashtag like it was some information. Actually, what the hashtag says is, if you take the 101st byte from the beginning, there's an encrypted blob, and to decrypt it, that's the password. That's what it's saying. And again, it's a JPEG. It's a JPEG hosted on GitHub. So you have a lot of information there that if you just happen to look at this Twitter user that was just created today and just tweeted that, it looked like innocuous, right? Nothing happened. It actually is setting a rendezvous site on GitHub with a lot of information. Yeah, comes from the Russians. According to FireEye, I can't verify this. Miniduke, which is a very well-known Russian threat, Russian meaning from the Russian government, supposed to be, is using the same exact algorithm with the same exact strategy, along with this thing called Hammertoss. So apparently it's the Russians using this. So somebody close to the Russian government, some department associated to the Russian government is using this. Why? to stay undetected as long as possible. So that was pretty cool. Actually, I remember the first time that I realized this a few years ago was that I had a customer, they're a pretty big customer, and they got a honeypot just to get a lot of samples, right? So in the honeypot, this particular honeypot that they acquired, they had a pretty cool feature, which is when it was infected, it records a video of the whole infection. Now, instead of just seeing attain normal infection, when people like this were infecting it, you could see that after that, there was a screen and somebody typing. And it was somebody because they started typing with mistakes, like you and I type. Oh, backspace, 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 net. And started trying to move laterally, trying to check stuff. So there was a guy. So it was kind of like, wow, so this is not automated malware. This is a malware that enables a bad guy to come in and start doing stuff. So we're not talking about being attacked by automated scripts. We're not talking about robots. We're talking about humans. You know, our enemy right now is a human. That's why I'm showing this, because it's somebody who is attacking us willingly. You know, it's not a random attack. It's just these attacks, right? The fourth category, and this is really unusual, and I like it a lot because I think it's a great idea. It's hiding stolen data. Now, you see that very rarely. No, hiding stolen data. Arnold shows us it's trying to hide something there. And this particular one was in Poland, and the Polish bank accounts had a very definite format. The format is like, I think it's 20 numbers, right? 20 digits. So this particular thread was targeting Polish users. So the aim was whenever you would see a Polish bank account number with that particular format, it would replace it by another one. So for instance, a PDF or something was being sent from the computer or to the computer that was infected, then replacing the bank account. Whenever there was a payment to be made, then it would show the fake bank account, and the money would go to the bad guys instead of to the real ones, right? It's just aiming at small companies. You know, small companies, they work a lot with PDFs. So they send you an invoice and please make the payment here, and then you make the payment, you confirm by email. Very, very non-techy stuff. So what these guys managed to do, it's a memory scraper looking for that and replacing bank accounts by a different bank account. Where do they get that bank account? They don't make it up. They make an HTTP request, and within the request, it's a nonsensical request such as /G4X6 blah 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 .txt, which doesn't even exist, right? Then it returns a 404. 404, which is it's a fake 404. Instead of not found, it's a not installed, which is a new HTTP thing that we have now. So, is it 404 site not installed, blah, blah, blah. And then, as part of the response, it has that blob. So, what that decodes to is the bank account, the Polish bank account that is being used to replace the real ones. So, everything is happening through HTTP inside, in the return, not in the request, which is pretty cool, right? Because in the request, it's a 404. When you're looking at, if it wasn't a not installed, it should be a not found. But if it was a not found, then any device looking at this communication would see just, okay, somebody's trying to look for a page, and it returns a 404. No big deal. There's nothing happening there. It's actually a lot happening. There's exchanging information. With this technique, you can actually go for an HTTP with, in the headers even, you can put all sorts of stolen information and return a 404, not found. So it's pretty cool. It's a pretty cool technique. It's really underused. I think it has a lot of potential, and I would expect that the bad guys smarten up and start using this at some point, because I think it's pretty inconspicuous. My conclusion here is, well, steganography, when you look at it from the technical perspective, is pretty cool. I mean, this is like the picture of being cool. The guy, perfect body, in the beach, with the woman, with the alcohol, really cool. So, I think it's pretty cool, right, steganography, until it's being misused and abused by bad guys. Because then you find yourself in the other side, right? You're trying to defend our users against it, and then you find yourself in a situation where it's very difficult to discern whether that communication that's happening, whether that blob of data that looks like a BMP is hiding information or not. And it can be pretty tricky. So stack analysis is not a real option in the real world because it just takes too long and it has a lot of false positives. Perhaps we have to look into it. Yeah, I don't know. For me, steganography is cool. When it starts being abused and misused, it stops being cool. And that was my whole point. I hope you like the thing. Just thanks very much. If there's any questions, yeah. You're thinking as the bad guy, right? Oh, it's good. Right. Change, yeah. Actually, when you have full control of everything that's happening, you can do things like that. I believe it's Google and a few more. Whenever you upload a JPEG or an avatar as a part of an avatar or something, they modify it. They resize it so that you never get, you know, if you're putting stuff inside the server, it will never be the same as what you uploaded. So that's happening already. Now, doing that, yeah, I think it's pretty common. Exactly. Yeah, so if you manage to put stuff inside the image, there's no guarantee. In fact, it's almost 0% chance that it's going to stay as part of the end result. When you have full control of everything, like a server, an HTTP server accepting information, then that's viable. If you're looking at that as a moving data from one place to the next, like a firewall, you know, just transports data, I'm not sure that would be viable, because if you have to resize every single JPEG or change every single JPEG, I don't know if that would be viable or not. I'm not sure. It's a possible solution. Any more? Sure. BMP is preferred because BMP doesn't have any encoding. It's just pixel after pixel. It's a you know, BMP, a map of pixels. PNG, I think it's GIF, but it has an open source zip. The bzip that it uses is open source. At the end of the day, it's same as GIF, but it can be used anything. It's a plain zip, so it's very easy to change stuff. Not so with JPEG. JPEG has an algorithm so that it encodes only one bit, and then the rest it infers. So JPEG is not used at all, but it tends to be either GIF, PNG, or BMP. What happens with BMP is that since it's a map of bits, it's just humongous. It ends up being super big, so it's not so used. Does that make sense? Yeah, and it's not worth it. It's totally not worth it when you can do PNGs. Because at the end of the day, you're not even aware that this is happening, right? You get infected, and then there's a request to HTTP, and it returns with PNG or whatever. So you don't even know what's happening. You know, you don't care. So it's not worth their time. Any more? It depends, but normally it's 1 to 8. So every byte encodes 1 bit. So if it's only a very like 255 colors, that's kind of crap, right? That's a very crappy gift. But if you put like say 4 byte per pixel, that's 16 million colors, 16,777,216, right? So those, then you lose a lot because then you encode 1 bit for every 4 bytes. That's a lot of information that you're missing out there. But yeah, it's up to you. I mean, steganography is just a tool. It's up to you to use it for whatever purpose you want. All right. Thanks very much, guys.